Hello everyone, my name is Halwa Filza Afiko. You can call me Halwa. I am from Physics Offering M. In this video, I will explain about one of the physical phenomena in our daily life. That is black object radiation. Before that, I will give one example about black object radiation in our daily life. When the weather is hot, some people definitely feel hotter when they wearing dark clothes than wearing bright clothes. For example, in the afternoon, when we wear black shirt, we will feel hotter than when we wear white shirt. In physics, it is explained that the surface of dark objects is easier to absorb heat than bright objects. This is known as radiant heat. This phenomenon also applies to other black object radiation. Every object must emit radiation from the color it has. One of the colors of objects that emit radiation is quite unique is a black object. Black objects have a better ability to absorb light. That's why, if we use black clothes, it tends to be hotter. And it is contrast, if we wear white clothes, we will feel cooler because white is reflecting light. We will now begin to discuss black object radiation. But the black object here is an object that is opaque and does not reflect light. Well, the so-called black object radiation is a thermal electromagnetic radiation that occurs in or around objects when they are in thermodynamic equilibrium with their surroundings. In simple terms, we can understand that black object radiation is when an object absorbs and retains light. The object will emit radiation to its surroundings so that we can feel it through certain temperature and color change. The black object absorbs all the energy it receives and no energy comes out. And on a white object, it can reflect all radiance energy. Therefore, dark object can absorb all light and light energy will gather and turn into heat energy. In physics, there are two laws about black object radiation. First, Planck's law. This law describes the density of the electromagnetic radiation spectrum given off by a black object in thermal equilibrium and a certain temperature. This law has a mathematical equation capital B sub V open bracket V point capital T close bracket equals 2hv cubed over c squared times 1 over ehv over k capital T minus 1, where capital B sub V open bracket V points capital T close bracket is spectrum radiance and H is Planck constanta, K is Boltzmann constanta, C is speed of light in a vacuum, V is frequency of electromagnetic radiation, and capital T is absolute temperature of the object. The second law about black object radiation is Wien's law of displacement. Wien explained about how the spectrum of black object radiation at any temperature is correlated with other temperature spectra. The mathematical equation is lambda maximum equals B over capital T, where lambda maximum is wavelength, B is displacement constant Wien, and capital T is temperature. And one example of the phenomenon of black object radiation is when we wear a dark clothes. So, light-colored clothes easily reflect the sunlight, while dark clothes have trouble reflecting the sunlight. Because of that, the dark-colored clothes traps the heat from the sun, and that's why we feel much hotter. That's all my presentation about physical phenomena. Thank you very much for your attention to me, and thanks for watching.